Good morning, ladies and gentlemen. It is an honor for me to be here, and I would like to thank the organizers for this thoughtful invitation. I take the opportunity to summarize in a talk almost 4 decades of research and development work in a particular area that I have started during my doctoral studies. And most importantly, I would like to open up the horizon for the challenges ahead of us and encourage the younger generation to continue work in this particular field. So, fasten your seatbelts. It will take me a while. I will start with an introduction to fundamental terms and concepts in the area. Oh, okay. No problem.
Sorry. Again. Δεν ξέρουμε γιατί. Αυτό ήταν.
Are we all set?
Yes.
Okay. So, let me start with some fundamental concepts. Inclusiveness. The term inclusiveness refers to the practice or policy of providing equal access, opportunities, and resources for people who might otherwise be considered or marginalized, such as those with disabilities or belonging to other minority groups. In the field of human-computer interaction, inclusiveness implies that products and services address the needs of the widest possible populations, irrespective of their age, their ability, and in this respect, digital accessibility constitutes a condition sine qua non for inclusiveness. So digital accessibility refers to the design and development of digital content, products and services in a way appropriate to ensure that they're accessible to and usable by people with disabilities. So for us, usability is an add-on to accessibility. First, you need to have accessibility and then usability. One cannot do without the other. I refer to inclusiveness as a fair and equal treatment of all citizens. The need for digital accessibility is therefore not only about people with disabilities. It is also about elderly, and that is especially important in a society that, as we all know, is globally aging. But it also concerns each one of us who can potentially find ourselves in conditions of temporary difficulty or even impairment. For example, if I lose my glasses, I'm temporarily visually impaired. And if I break my arm or my leg, then I become temporarily disabled. So we're talking about equity and not just about equality. That's the difference. In equality, each person is given the same tools and equal opportunities. In equity, however, the particularities of each person are recognized and they are given exactly those additional resources and opportunities they need in order to achieve an equal outcome. For example, in this picture, if everyone has the same podium, regardless of their height, this eventually leads to inequality, since the shorter one does not see the race. But if everyone has the right podium, the most appropriate podium, so that they can see over the fence, then we have equality. Let's look at some important statistics. According to a 2021 report by WHO, the World Health Organization, more than 1 billion people worldwide live with some form of disability. This represents 16% of the world's population. At the same time, all countries in the world face challenges due to the aging population. Aging, according to a report by WHO for the year 2022, the number of people over the age of 60 was greater than children under the age of 5 in the year 2020, while there is a prediction that in 2050, the global population over the age of 60 years will double from 12% that it is now to 22% compared to 2015. Digital accessibility has been addressed as an important issue among researchers and practitioners in the field of ICT, information and communication technologies, since the early 80s. Remarkable advancements have been made since then, initially with the so-called reactive approaches, employing assistive technologies, and I will come back to the definition of what is assistive technologies, and a posteriori product adaptation, a posteriori afterwards, to provide access to applications and digital systems that were originally designed without considering disabled people. Soon, it became evident that this approach was not capable of keeping up with the rapid technological evolutions, was often cost ineffective, and more importantly, unable to deliver the promise of equitable access to all, as they often resulted in loss of functionality after adaptations, were unable to respond in time to rapid technological developments, and could not effectively address the great diversity in the types of disability and the dynamic changes in the condition of each disabled individual. In our modern world, our computer is no longer a stationary computer, as in the past, when used in our office or at work. Today, new dimensions of diversity emerge during our everyday interaction. So this concerns the profile of the end users, in other words, needs and preferences, the context of use. Are we in the office environment? Are we in a public space? Are we driving a car? Are we in an outdoors environment? The specific technological platform that we're using, is it a computer, a mobile device, a kiosk, etc. And the type of work performed with a digital system. Is it professional, educational, medical, and the like? From the late 80s, it became apparent that reactive approaches could not meet the need for equity, as we defined it earlier on, in the field of digital accessibility. Thus, the need for more radical approaches, which take into account the need for accessibility from the design phase became understood as an imperative. In this context, 3 decades ago, we took the lead in research and development efforts that led to proposals for new concepts, new principles, new frameworks, new methodologies, new techniques formulated as approaches for design for all and universal access. Our proposals were published and they were presented in international forums, and they gradually gained acceptance. At this point, I'd like to make a small parenthesis we can discuss later on. There are, in the text that I have given yesterday as a background document, there are some references. And out of those references, there are 4 white papers which I consider important. 2 relate in the past, in the 90s. Those 2 are talking about an information society for all in terms of principles and a research agenda. Those white papers were funded by industry, and they were funded also by the European Commission. As a result, in the year 2000, in Lisbon, we had the European Commission initiative called Information Society for All, towards information, e-Europe, towards Information Society for All. These are all easily accessible also in the website. And also on the other side of the Atlantic, the National Science Foundation adopted as a result the Universal Access Program. Now, more recently, in the last few years, there are 2 other important white papers. One is the 7 HCI Grand Challenges, published in 2019. And even more recently, there is one about 6 Grand Challenges in user-centered design. This was led by Professor Ben Schneiderman. And that also gives some answers to the questions, what do we do with human-centered AI, and what is the next steps that need to be taken in this direction. So borrowing the term from architecture, it was a small story. It was a poster in the late 80s, which had an environment with a lady pushing the baby, but also outside the supermarket, pushing, if you like, the carriage. And the idea came into mind, how can you transfer from architecture to ICT, the same concept, design for all? So this was a term that came from architecture, not from ICT, but we borrowed it. So that's when we introduced in the early 90s the concept of design for all, in general in ICT, and more specifically in human-computer interaction, as an approach to achieve universal access. It implies an explicit focus on systematically and proactively addressing diversity in the design of digital technologies. In this context, intelligent user interface adaptations has surfaced as a solution for catering for the needs and requirements of a diverse user population in a variety of contexts of use. In view of a globally aging society, this becomes much more important. It became imperative to extend digital accessibility to also consider the needs and requirements of the aging population. The need for more radical approaches, considering accessibility by design, gave rise to the concept of universal access, which aims at the provision of access to anyone, from anywhere and anytime, through a variety of computing platforms and devices, to diverse products and services, digital services, Universal access encompasses several dimensions of diversity, as we saw in the previous slide. It is achieved by following design principles and practice that ensure that interactive products and online services can be accessed, used, and enjoyed by all citizens. Sometimes there is a misconception that digital accessibility only refers to people with disabilities and, as we said, the aging population. But this is not true. It affects every one of us. If we drive a car, while driving, we are visually impaired functionally because our attention should be elsewhere. Otherwise, we're going to have an accident. When we cook and our hands are dirty, we are in a difficult situation because we are temporarily motor impaired. Imagine to have with dirty hands to interact with a device. In a situation where we have intense stress, we may find ourselves in conditions of mental dysfunction. Imagine having to read long texts with complex instructions that we need to apply step by step right after an accident. The provision of equal access to digital services to every citizen, including persons with disabilities, has been now recognized worldwide as a fundamental human right and protected through national constitutional provisions and laws, as well in international agreements. Most notably, the United Nations Convention on the Rights of Persons with Disabilities, which was constituted in 2006 and entered into force in 2008. 2 European directives in 2016 and 2019, which are now laws of all member states. And national legislation, which also takes into consideration the de facto standards that emanate from W3C, Web Accessibility Initiative. And W3C provides details of what's available on policies across the world. So, milestones in the adoption of rights of persons with disabilities by the United Nations. It is interesting that after the foundation of the United Nations in 1945, soon afterwards, in 1948, we had the approval of the Universal Declaration of Human Rights. But it is interesting that there was no explicit reference to people with disabilities at that point in time. So it was much later on than this has become an explicit mention, as I said, and recently, and by that I mean this year, at the 16th session of member states that have signed the Convention of Rights of Persons with Disabilities, Greece has provided recommendations for addressing the issue of non-compliance to legislation regarding existing specifications for universal accessibility of websites and digital services, but also proposals regarding required preparations for addressing upcoming challenges related to accessibility in the emerging digital world of smart environments and AI-enabled systems. I promise to give some definition about assistive technologies because that's what we started working back in the 80s. So endeavors in the field of digital accessibility and universal access have initially focused on advancing the accessibility of desktop computers, and initial efforts mainly focused on the provision of assistive technologies. Several definitions have been provided for assistive technologies, According to WHO, the World Health Organization, in 2016, assistive technology is the application of organized knowledge and skills related to assistive products, including systems and services. And an assistive product is any external product, including devices, equipment, instruments, or software, specifically produced or generally available, the primary purpose of which is to maintain or improve the individual's functioning and independence, and thereby promote their well-being. Assistive products are also used to prevent impairment and secondary health conditions. Popular assistive technologies include screen readers and braille displays for blind users, screen magnifiers for users with low vision, alternative input and output devices for motor impaired users, for example, adapted keyboards, mouse emulators, joysticks, binary switches, and the like, or specialized browsers and the text prediction system. Over the years, assistive technologies have provided suitable solutions to many problems of individuals with disabilities, and they are not likely to disappear from the market in the future. In fact, they are indispensable. However, with the evolution of technology, more proactive approaches to addressing accessibility started to be investigated, leading to pioneering research on universal accessibility software. Work towards this direction in the 90s first introduced the concept of dual user interfaces. User interfaces exhibiting both a graphical and a voice-based interaction, so as to be accessible at the same time from the sighted and blind users. This is fostering collaboration. This was the work of a master thesis presented at the CHI 1995 in Denver, Colorado. The concept was subsequently extended to cater for the design of user interfaces which would potentially adapt to any type of human function limitations, advocating comprehensive and systematic approaches to user interface adaptations, which are based on the principles of design for all and promote the practice for universal access. In such approaches, user interface adaptations constitute a vehicle for efficiently and effectively ensure the accessibility and usability of user interfaces to users with diverse characteristics, supporting also technological platform independence, metaphor independence, and user profile independence. This implies the provision by design of alternative interface manifestations, the availability of knowledge regarding the abilities, the requirements and preferences of the target user groups, as well as the characteristics of the context of use, and finally, the availability of decision-making logic capable of making adaptation decisions either before the start of the interaction or at runtime during the interaction. This work was supported by the European Commission through the Access Project and was the PhD thesis of some of my students, leading to several publications. Then we had the application of this approach in several directions, including web browsers, text editors, games, tools for developing adaptation-based universally accessible interaction, as well as extensions of operating systems to enhance their inclusiveness. Then we had the application in the 1980s and in the 1990s. we were concerned about citizens' access to the information society. However, these days, following a series of profound paradigm shifts, we have revolutionized the way we interact with technology and the world around us. So, with the permission of the chair of the session, at the end of my presentation, I would like to start posing a question to you. How many paradigm shifts did we have since the 80s? How many transitions? Being able to answer this question through our experience, not necessarily through my presentation, it will be important to realize also what's going to become the situation ahead of us. A major constituent of this change was the paradigm shift introduced by the web. So I give you a hint on the one hand, and mobile devices on the other. That's a second hint. Empowering users to have a mini computer in their hands. So starting with web accessibility. In simple terms, web accessibility means that websites, tools, and technologies are designed and developed so that people with disabilities can use them effectively. More specifically, people can perceive, understand, navigate, interact with the web, and contribute to the web. A key development for the pursuit of web accessibility was the first version of the Web Content Accessibility Guidelines, published for the first time in 1999 by W3C Way. So the goal was raising awareness of web accessibility, otherwise it would not be achieved. But these guidelines have become the basis for legislation in numerous countries around the world, and now constitute de facto standards. The content guidelines have undergone several revisions. At this point in time, we have WCAG, as it is called in short, 2.1, but 2.0 is still applicable. And by the end of the year, it is expected that we will have the new version, 2.2, which comes into play, we use it, but does not predicate, does not supersede the previous versions. So, given the importance of ensuring digital accessibility, which has been recognized by legislation, but also the developments in the field of technology, where a multitude of guidelines and techniques have been developed to achieve web accessibility, we would expect that websites to develop today would be accessible, but they're not. A recent study earlier this year in 1 million homepages around the world highlighted that 96.3% are not accessible. In fact, nearly 50 million errors in those 1 million sites. To be precise, 49,991,225. So approximately 50 issues per page. Incredible, but true. We'll come back to see what can be done about it. Moving on to mobile accessibility. Mobile devices have become an indispensable part of our daily lives, permeating various aspects of our everyday life, of our routines and interaction, allowing us to stay connected through calls, messages, and social media platforms. Moreover, mobile devices serve as gateways to the vast digital landscape, offering a plethora of applications for entertainment, productivity, education, and much more. Mobile devices have also been embraced by people with disabilities, with statistics indicating that they are more likely to own a smartphone rather than a desktop or laptop computer. Mobile devices have been reported to provide assistance to individuals with disabilities to perform their daily activities at home, at work, on the move. Mobile devices functionalities employed by users with disabilities include texting, internet access, email, social media, maps and GPS, voice calling, and video calling. Applications that non-disabled persons also use on a regular basis. A recent study exploring the accessibility of 479 mobile applications through assessment with an automated tool, and there are many of those around, people can download either free or with some fee, highlighted that there are accessibility violations in the vast majority of the studied applications. The identified problems mostly pertain to lack of element focus, missing element description, low text color contrast, lack of sufficient spacing between elements, and less than one minimum allowed size to text fonts and other elements. There are many such technical details that need to be addressed. Similar results are reported by another study also employing an automated tool to assess the accessibility of 2,270 mobile applications, indicating that the majority of the studied applications contain at least one accessibility issue and identifying 86,767 accessibility problems in total. The issue types mostly pertained to the size of the touch targets, text contrast, item labels, image contrast, and item descriptions. So there are many studies out there, and there are many publications in conferences and journals looking at these problems. It is a current problem that needs to be more systematically addressed, providing solutions. Video games. Video games provide multiple advantages to people with impairments, according to large-scale studies and with disabled gamers. Game experiences are seriously hindered by poor accessibility options. 66% of gamers with an impairment face barrier-related issues to gaming, whereas 40% have faced adverse perceptions from fellow gamers regarding their disability. Given the recently elevated interest in the field, modern games include at least some accessibility features. However, the specific features embedded in each game and their extent varies greatly. There is a lot of variability. At the same time, a plethora of guidelines for accessible games is available in the literature for those who are really interested to apply them. Several games which are accessible to players with disabilities have been developed and are reported in the literature. Moreover, there are several games which have been reported to be accessible by players with multiple disabilities. The slide also shows a couple of examples, but there are many more games with accessibility features, some of which are fully accessible for individuals with specific disabilities. So there is a variety of issues there. In the field, finally, of game accessibility, notable progress has been achieved. However, there is significant potential for enhancing the current situation, as numerous mainstream and independent studios often disregard published guidelines. An additional concern regarding game accessibility pertains to collaborative or competitive multiplayer games and the isolation of players with disabilities. Team playing is a valuable experience, allowing teammates to form bonds, work on strategies, and pursue victory together, cultivating trust and developing skills such as leadership and team cognition. Unfortunately, multiplayer games are pushing away gamers with disabilities. Persons with disabilities play multiplayer games less due to insecurity about their own skills and lack of relaxation while playing, stemming from the lack of game accessibility and the lack of support in collaborative or competitive gaming for people with different abilities. Assessing the status quo. In summary, remarkable progress has been noted in the field of accessibility across various application domains. However, despite the fact that digital accessibility is a fundamental human right and mandated by law, it is noted that serious accessibility gaps are reported across most technological domains. It is also noteworthy that guidelines to achieve digital accessibility and research results reported in the literature are abundant. Official reports by all member states are mandated by the European Commission, and this is done on a regular annual basis. And repeatedly, they report lack of accessibility. And there is concern about what additional needs to be done to address this continuous issue. So the question that needs to be answered is why this notable lack of accessibility is observed. Several reasons have been reported by software engineers, including insufficient awareness regarding accessibility and compliance requirements, lack of their comprehension of the guidelines, lack of appropriate tools to support the development of accessible applications, industry's lack of interest in accessibility, but this will have to change from June 2025 as the new directive sets a deadline for all websites, not just public, but also private websites to be accessible. And absence of accessibility as a topic in academic curricula worldwide. So let's now move to a new emerging technological field. Extended reality refers to the collective range of taxonomies of the reality-virtuality continuum, including augmented reality, mixed reality, and virtual reality applications, and refers to the fusion of layered objects into the real world of immersive digital world. Benefits and uses of XR technologies have been reported in the literature for individuals with disabilities and older adults, mainly in the context of education, healthcare, and well-being. Indicative examples include, but are not limited to, VR for training, wayfinding skills, virtual reality for construction and spatial knowledge to assist the exploration of architectural spaces, augmented reality-based annotation tool for detecting and labeling salient objects for assisted indoor navigation applications, augmented reality for enhancing the perception of low vision users with regard to their surrounding for safe navigation, VR systems for rehabilitation, etc. Thank you. No, I have not finished. And since it is offered, I might as well take it. We're getting there. Don't worry. So, interaction challenges. Numerous challenges arise for users with disabilities when interacting in XR environments. The list is long, but I will give few examples. For persons with hearing impairments, challenges in lip reading due to poor rendering in distinguishing subtle differences in busy visual and audio environments, or lack of visual prompts, etc. For persons with physical impairments, usability of controllers, requirements for dexterity and speed, maintenance of postural stability and balance. For persons with visual impairments, lack of integrated audio descriptions, challenges in navigating the virtual environment, perception of others and interaction with them, etc. For persons with cognitive, learning and neurological impairments, implications of complete immersion in well-being, cognitive overload, input and hand-eye coordination, etc. Design guidelines have been proposed in the literature to assist development in creating accessible XR environments. Several tools have also been developed. For instance, a haptic cane controller that mimics white cane interactions, empowering individuals with visual impairments to navigate a virtual environment by transferring their cane skills into the virtual world. Audio-based interaction has been proposed as an effective solution to provide navigation assistance to the visually impaired in virtual environments, such as through 3D soundscape that simulates the sounds that the user would hear in a real-world environment. Software to adjust background and text colors, brightness, and magnifications, as well as supporting interaction colors, auto reading, and captions. Nevertheless, most XR environments today remain still inaccessible. In view of the new paradigm in metaverse, which promises to remove boundaries and borders, becoming a decentralized entity for everyone to use, forming a digital virtual layer over our own real world, the need for inclusivity and accessibility becomes even more prominent. In such a disturbing and socially influential new technological landscape, it is important that accessibility is not pursued as an add-on or in a dedicated fix applied to a particular virtual environment. Instead, it should be embraced as an a priori consideration, allowing the adaptation of the environment and its contents to dynamically conform to its users' disabilities a requirement which accentuates the call for universal accessibility of future emerging technologies. And now we go into intelligent environments. Throughout the literature, several definitions have been provided for intelligent environments. To summarize and simplify, we would say that intelligent environments are digital environments that include interconnected embedded devices capable of detecting and recognizing people and objects, as well as inferring their intentions. Their intelligence is harnessed through context analysis, responsiveness to human actions, adaptability to their needs, as well as their potential for learning. User experience design in smart environments is a complex undertaking due to the intricate interplay of various factors, one of which is accessibility. Technological complexity in intelligent environments arises from increased interaction with technological objects that are abundant in the environment. Seamless integration of technology within the environment renders interaction less obvious and often indirect. Complex decision-making process occur, which may prove puzzling or opaque to users. Natural interaction techniques that are often difficult to understand and execute, for example, to find out which gestures or voice commands are supported by a system. Moving to implicit interaction, I already mentioned that the interaction is no longer only direct, but also indirect. That is, we do not activate the response of the environment or its specific functions in ways we already know, such as pressing or touching a button on the screen, but also in other more indirect ways. For example, the user's emotional state can trigger an action from the intelligent environment. In the image next to it, we see an example from a system that we have developed in the context of our ambient intelligence program, which adjusts the lighting of the room and changes the images projected on the wall based on an assessment of the user's anxiety. At the same time, the interaction is also silent. Actions of the environment and the system in it can be caused by a variety of factors beyond the control of the user themselves, such as the state and action of other devices and the state and actions of other users, or even by the environment itself. Natural interaction. We use natural interaction techniques, for example, through voice commands or gestures. We can actually exclude disabled people if we're not careful. Touch interactions, the most commonly used method of interacting with smart devices, can hinder the interaction of people with mobility disabilities. Voice interaction, which is often used to interact with smart assistants, poses obstacles to the interaction of people with speech disorders or hearing problems, and of course, also for the elderly. Opportunities. Despite these challenges, intelligent environments also provide new opportunities for accessibility. These environments incorporate multiple interactive and distributed units, thereby presenting alternative means of interaction. For example, an individual's personal device, most likely equipped with all the necessary assistive technologies, can serve as their integrated means of interaction and digital access to the intelligent environment surrounding them. Intelligent environments are inherently multimodal, as they support multiple methods of interaction concurrently, allowing each user to opt for their preferred accessible method of interaction, tailoring the experience to other specific needs and preferences. System output, accordingly, can be provided via multitude channels to suit the perceptual needs of the different target user groups. Furthermore, automating tasks and activities solves physical and digital accessibility issues, but also makes it easier for users to complete frequent or repetitive actions. And now the much awaited, as of yesterday, digital accessibility and artificial intelligence. AI has permeated many everyday life activities and has become an integral part of various sectors. AI and machine learning are used in health, justice, finance, business operations, and industry, providing new opportunities and uncovering at the same time major challenges, including, amongst others, ethical, legal, and transparency issues. A pivotal issue and pressing concern is also the inclusivity and accessibility of AI. A major issue which needs to be addressed is algorithmic bias against individuals or entire social groups, including persons with disabilities, older adults, as well as vulnerable individuals. Discussion on AI biases is already rich in the literature, with potential sources or bias identified as dataset bias, association bias, information bias, interaction bias, and confirmation bias. As illustrative examples of bias pertains to the training datasets used for face or voice recognition algorithms, which do not include people with disabilities who might have different facial or vocal characteristics. As a result, an AI-empowered disease detection system entails the risk of failing to detect a disease simply due to the disability of the person being examined, for example, a person with Down syndrome. Another accessibility challenge pertains to transparency of AI systems. Users should be able to understand the decisions of an AI system, however complex they might be. This is current research topic in the field of explainable AI. However, accessibility issues have not yet been studied. One way in which AI systems provide an explanation of the decisions they make is through visual explanations, such as feature important graphs. In the above image, AI has shown the point in the image that led to the conclusion that there is a dog in the image. The points of the image that led to the decision are mainly the dog's ears and nose. But this fact is not clearly explained to the user. Imagine the complexity of explanations in more complex environments and contexts of use. At the same time, the visual explanations are not accessible to users who are blind. In addition, they often use complex charts that are difficult for the general public to understand. It is clear that the design of AI explanations should be carried out according to the principles of universal access. Another important problem is the lack of human-centered design in AI systems. In particular, these systems are designed by software engineers who mainly are concerned to develop algorithms, prepare the dataset, train the model based on the data, debug, and evaluate the system. Validation of results is often performed by experts, but rarely do end users participate in the decision, development, and evaluation process of such systems. However, acceptance of AI systems by the end users requires the active participation throughout the system development lifecycle. Following the approach of human-centered AI design, it becomes crucial to prioritize human values and requirements, positioning individuals at the core of AI system design and ensuring that the development systems can truly address the diverse user needs and requirements in an optimal approach that epitomizes transparency, understandability, and user-friendliness. Opportunities, again, besides the identified challenges, it must be acknowledged that AI-based approaches bring significantly potential to contribute to the wider practice and adoption of accessibility. For example, AI offers a great potential for fine-grained adaptation of user interfaces and interaction through machine learning-based user modeling and runtime interaction monitoring. Harnessing AI's capabilities in pattern recognition, natural language processing, and machine learning, tailored applications have been developed to cater to specific needs of individuals with disabilities. For example, computer vision AI systems have been developed to provide real-time assistance to individuals with visual impairments, providing acoustic information regarding the location, identity, and gaze direction of nearby people, detecting obstacles, or recognizing objects. Innovative AI systems for non-standard speech recognition can revolutionize augmentative alternative communication technologies, addressing people with speech impairments. Addressing the needs of persons with physical impairments, a wheelchair can be driven using facial expressions and have been developed, in fact, employing neural networks and image processing. Text prediction systems have also been proposed to assist persons with disabilities in producing text faster. Reading assistance for persons with disabilities, and in particular dyslexia, assist them in comprehending of written text. I already mentioned the need for end-user involvement in the design of digital systems. The next step we should now consider is human-centered AI design for all, corresponding to the concept of design for all that we have introduced 3 decades ago. I also mentioned that human-centered design approach involves the active participation of end users, experts, and stakeholders in the iterative process of designing and evaluating an ICT product or service. In the case of AI, this means that end users must also be actively involved throughout the system design, development, and evaluation cycle. We must acknowledge that this is a far more complex process if we're addressing the public at large due to the increased technical parameters involved, such as selection of the appropriate dataset, model development, validation of AI decisions, etc. It is an uncharted research area, currently without clearly defined methods and protocols, with lots of work that needs to be done. Therefore, taking the next logical step, we are now talking not just about human-centered AI design, but human-centered AI design for all. So the design for all concept of the early 90s becomes the human-centered AI design for all 3 decades later. It is a design that promotes inclusivity and aims to ensure that everyone, anywhere, anytime, is not excluded or discriminated against by smart environments and AI-enabled systems due to disability, age, origin, gender, socioeconomic status, experience using technology, etc. Like before, this approach seeks inclusiveness in a proactive and systematic way from the beginning of the design. Retrospective approaches and modifications are now considered much more difficult to contemplate, and they are unlikely to succeed. So what are the open challenges in front of us? Capturing the evolving needs of users in smart environments and AI-enabled systems. Creating new, more appropriate user models, the traditional user modeling. Extending human-centered design methods to IT or ICT environments. And apply principles of design for all and universal access to all phases of developing intelligent environments. Conception and development of new technological solutions. Conception and development of new methods and tools for automatically creating accessible multimodal user interfaces. And finally, creation of new evaluation methods and tools for a holistic evaluation of accessible user experiences. As an epilogue, endeavors in the field of digital accessibility, spanning the entire spectrum of technological domains under scrutiny, can be broadly categorized in 2 main types, namely research-driven and policy-oriented approaches, as well as technological solutions and tools. The first category entails studies on the accessibility barriers and challenges faced by users with disabilities, guidelines for the design of accessible digital products and services, as well as legislation and standardization efforts. Developers in the second category include solutions to assist persons with disabilities in overcoming barriers in everyday life activities. Accessible technological products and services, for example, websites, mobile applications, games, extended reality applications, etc., as well as more generic approaches such as tools and frameworks to foster the development of accessible software. As evident influence, excuse me, as evident inference drawn from comprehensive analysis across domains where digital accessibility research and practice is well established, is notable disparity between scholarly exploration and real-world application. Despite the considerable corpus of knowledge that has been developed over the years, the legislation that has been enacted and is in place, and the de facto standards that have been established, in practice, there are major accessibility problems manifested in the products and services developed, even in the case of straightforward mainstream products, such as websites. This fact of conformance to legislation, accessibility guidelines and standards has been attributed to several reasons, including the intricate nature of the undertaking, the seemingly complexity of the existing guidelines, insufficient education of software engineers, the lack of appropriate software tools, as well as resource constraints imposed by business workflows. Under a forward-looking perspective, it is apparent that the gap between policies and practice is expected to increase further. And this is the paradox. As we move from the by now well-defined accessibility issues to the yet uncharted territory of digital accessibility in intelligent environments and AI-enabled systems. In the emerging, more complex technological context, such as that of intelligent environments and AI-enabled systems, technological failure can potentially have much more serious consequences. At the same time, increased uncertainty is raised as the skills that become necessary for all of us as users of the rapidly evolving technology are constantly changing. Moreover, the aging of the population is a permanent and ever-increasing challenge. As we get older, we have many impairments and disabilities. In this context, we consider it necessary to propose the human-centered AI design for all approach. This is proposed as an approach to achieving an inclusive society where all citizens, regardless of their origins, characteristics, or abilities, will have equal opportunities and will have an equal share of the emerging technological prosperity. Envisioning and planning for a future wherein digital accessibility seamlessly transfers research outcomes to practice demands a multifaceted approach. This involves nurturing ongoing research efforts and updating the education of software engineers. Moreover, the development of appropriate methods and tools is required to equip developers with ready-to-use accessibility solutions to achieve digital accessibility. This transformative journey also entails a shift in current development practices towards human-centered design approaches, and in addition, competent national authorities should undertake the responsibility of certifying the accessibility of digital products and services. Thus, a collaborative effort is required that includes educational reform, technological developments, and robust certification procedures. I thank you for your patience.
For this very inspiring journey, if I may say, combines many times and many papers and disciplines for human interaction. Then I'd like to open the floor for questions.
Can I ask my question first?
Yes, correct. Please, go ahead.
The question was paradigm shifts. How many transitions do we have since the 80s and today? And we can count them. Anyone can answer. We are going to interact here.
I would say 3.
Okay. Yeah. Instead of giving a number, can we actually name the transition from to?
The desktop, the web, the mobile.
Okay, very close. Let me go one level down. When we say desktop, let's say from DOS character-based to graphical user interfaces. That's number one. So from graphical user interfaces to the web, 2. Then to mobile. And then extended reality. And then AI-based, AI-enabled systems. So there are 5 in transition.
Still not there.
We have a disagreement here.
If we're still in the discussion of the transitions, I'm okay.
Let's finish.
I would like to.
Let's finish the transitions first.
Transitions.
Yes.
Okay, I give you a slightly different reply to that.
Okay.
I think we changed styles of interaction, which is very important. And as you said, we started with DOS, which is linguistic, simple language models. We went to direct manipulation, graphics, and interacting, and then remotely interacting, etc. But now we go back into the language model. If you're very careful, I mean, the new trend now is to either talk or type questions and talk to intelligent machines. So AI is, I think, is too broad a term. We should make it more precise. And now the current big wave since November 2022 with ChatGPT and those generative models, I think is the prevailing linguistic interaction, which is a new paradigm. It's an old one, but it's in a new form, which changes the way we interact with technology a great deal. And we're going to look at it and follow it in the future. But can I, since I have this, ask just a couple of questions? Thank you first very much for the talk. We really have great respect to your work. You're an evangelist of inclusiveness and design for all and all this terminology, which is basically to you and your group, and you're leading the area for many, many years. We really are thankful. We're lucky as a Greek HCI community to have you among us. Really big respect to all your work. And thank you for the talk today. A question which I have, and it's a personal question, and I would like your reflection to it, is the following. Design for all, it's a very good term, okay, but all, it's really, is it possible for all?
Most.
That word, okay. So most means we start already creating a boundary. I mean, we cannot accommodate it. I have in mind the famous physicist, is dead now, Stephen Hawking. He was a bright mind, really contributed a lot to theoretical physics, but he had a great disability. He had this muscle issue. Now, we put a lot of technology contribute to this guy in order to help him continue producing work in the area of physics. I mean, can we afford as society to do everything for every Stephen Hawking that exists in the world? It's a bit hard to say no, perhaps, because there are huge costs relating to define this all for including everybody. So we have to draw a boundary. Who draws this boundary and how wide it is, first of all. Second question. I didn't see very much in your talk talking about costs. Is it expensive to include more and more design for all approaches, issues in projects? I think you somehow make references to lack of knowledge of software developers, software engineers, designers. I'm not sure about that's a big issue. I mean, if I'm a company and I develop technology, and if the specifications include this as specs because I have to deliver, then the designers and the developers will do it. So it's not lack of knowledge, it's more lack of, to start with, of drawing this boundary, knowing which one, what what is the purpose of it. So I would like your reflection on why are the systems we have around it are not as expected. I've listened to a talk by Professor Katsanos yesterday. I don't know whether you were around.
I was.
Yeah, so he's done this 70, I think, public domain websites, and he said the situation is not as good as we would expect. I mean, why? What is the problem there? What is the issue? Is it because we don't have as a society? We're talking about Greek websites, but it's more general, I think. We don't have the resources to buy more inclusive designs, or is it part of the process of specifying the big projects, especially in the public domain? So these are some of the reflections I would like to hear from you. Thank you for your talk.
Thank you. Great questions. I'd like, with your help, to go and answer each one of them. Starting with the definition design for all. Right from the beginning, we said design for all, but what we really meant and what we had really documented always was design for most. It is impossible for all, but it is a very nice catchword that everyone would like to hear, okay? So there is no doubt that for all 100% does not exist. Having clarified this, let us move on to how we have been approaching this. It is impossible to deal with all categories of people with disabilities because, without going into details, there are cases that you need to expend tremendous resources for very little return on investment. So what has been happening over many years is that there has been a constant improvement of the situation, but asymptotically trying to get to a better stage. So as long as we all understand that the demands will be always much, much more than what you can achieve, then it's okay. And as long as there are movements in the right direction, as opposed to making some steps forward and then going sideways or going back, as has happened as well. So then the critical issue which you have rightly raised is about resources. And by resources, I mean predominantly money. But not only that, you need other type of resources. You need attention, you need knowledge, you need all the sort of things that we have been doing and have been achieved over the years. Now, society can afford at every given point in time so much, and there are always forces left, right, and center competing for the same resources. So what we see now is that the disability movement is gaining increasing attention, and therefore they're achieving step by step more. But we're not going to see this step function. You're going to see a progressive improvement of the situation, and I think it's good. And at the same time, and now I'm going into another level, legislation has been a very important tool for achieving progress. Standardization is helping legislation. And here we have the de facto standards. And then you also mentioned the knowledge and competence and education of software engineers. This is something which we have very closely studied and addressed. And yes, particularly in the case of web accessibility issues, the guidelines are there. And yet the way these guidelines are applied by knowledgeable software engineers is not 100%. And there are reasons for that. And we can debate what are those reasons.
Maybe you can pause on that because we are a lot of the time, I guess. Maybe just have time for a couple of short more questions. Maybe.
No problem. I'm at your hands. Thank you.
Thank you. Thank you for a great talk. Really, really interesting in all its extent. A couple of points, quick ones. We talked about all universal, and you probably mentioned that all is not someone with some, like accessibility issue, etc. Meaning impairment or something. Is accessibility an extreme paradigm of personalization you talked about? Is a need an extreme example of a preference?
Okay, if I understood the question, yes, personalization, individualized solutions for everyone, including people with disabilities. So the issue of addressing individual needs resulting from whatever cause, disability is a major one, is a way of helping these individuals. And how you do it? Well, technologically speaking, there are two approaches. One, we have the so-called design time adaptation. In other words, at the start of the interaction, the system knows who the user is, what are the user profile, what is the total user profile, what is the interaction platform, and what is the context of use, and what is the purpose of the interaction. And then we start the interaction. And then we enter into the second world, which is runtime adaptation, meaning that one of the 4 dimensions or more may change.
Yes.
And then you need the intelligence of the system to monitor and adapt accordingly.
So we could say that assistive technologies are adaptive systems to an extreme.
Hang on. Let's differentiate the use of assistive technologies. From the 80s, assistive technologies have been there predominantly to help bridge the gap. Okay? Assistive technologies are still needed under the concept of universal access, design for all, whatever, because you need those tools, those devices, this software in order to bridge the gap. But let's differentiate between the principles and the practice. Assistive technology is the practical way of doing things.
Thank you. And on a second note,
yes,
you mentioned accessibility in AI.
Yes.
But all your reasoning, rationale examples were referring more to the interface towards the AI system. And I was wondering, is there accessibility in the core system, the algorithm? Because other systems are also not AI-based systems, like traditional, let's say, systems. But
what I tried to say, perhaps not successfully, is that what you need is to consider the issues of accessibility throughout, from early design until validation of the system. And in human-centered AI, you have a number of issues. And for each one, you need to ask the question, how am I influenced by the fact that I'm not talking about the average user, I'm talking about the user?
Isn't this still an interface interaction issue?
It is.
For the last question, because this is big topics, and thank you for raising them, but I think the questions need the panel.
Dear Stephanidis, thank you for the flight. We said in the beginning to lock our belts, and I really enjoyed the flight over the assistive technologies and all these nice things that you said. But I have a question that you said that after 3 years on accessibility issues, only 4% of the main websites follow the guidelines of accessibility issues. Do you see that the same will happen in the future about the AI tools, that only 4% maybe of the AI tools will use the human in the loop to an AI accessibility for all issues? And next, I will also think, I would say about the another maybe research topic of a research topic about HCI is what about the performance of AI tools? I mean, maybe we'll not talk only about accessibility, but about the performance for all, because the AI models have different performances, and maybe the next AI tools will give low performance to all of us and keep the highest performance and the precision of the modeling, the predictive power of these models, in especially a group of other people that pay for this, and all the other people were not able to use the highest levels of precision and the higher performance of this predictive power of the tools. Maybe maybe we'll talk in the future about performance for all. This is an issue. And just to add something about your question, that I believe that another transition is from Web 1 to Web 2, since we came from just readers to content producers, which is of very much importance for HCI also, because all we need to put content in the web, not just reading. This is my question.
Yes, that's briefness.
Yes. Let's start with the last one first. There is no documented typology. It is for the first time that I thought of these paradigm shifts, if you like, and I said, okay, I will throw it in the audience, if you like, and get some feedback. When you do it properly, then you need, of course, to take into consideration all the details. And whether you mention Web 1 and Web 2 as two different transitions, it's something we need to think about carefully when you do it, this categorization, this taxonomy, if you like. Okay. Now, to go back to your first question, how do we compare what is happening now and still have got inaccessible results to what might happen with AI-enabled systems? Coupling this with the earlier attempt to answer to Professor Avouris' question, it is a not straightforward answer, in the sense that there are many issues, many considerations why this is happening. And yes, we have analyzed this. And I know the multitude of answers is not a single answer, is many partial answers. And the total is what is resulting in this, what we see. And it's not for lack of effort. People are doing it, and they're doing the best they can. But the result is there. And we cannot dispute this result. And tomorrow, if we do the same, we will have similar results. So there is something that needs to be done. And this we can discuss later. Now, the last question is about AI. I think I need to be a little bit careful here. The reincarnation of AI these days is introducing many things. For example, the LL models is now presenting a different manifestation. What will be the situation in 6 months, 12 months from now? I don't know. What I do know is that all the manifestations of AI need to be reevaluated, reconsidered under the perspective of universal access. We need to think carefully, and this has not been done. That's why I said from the beginning, and even yesterday, when we're talking about AI-enabled systems, let's not rush into either dictating or telling that it is something we have studied and these are the results. The answer is no. It is an open field at the moment. And I'm very careful into saying I have a solution. What I can say now is that from the preliminary evaluation of the situation, we have huge opportunities and huge potential problems. And we need to study both.
Thank you very much.